Um, in gaming, AI is used a lot, but also the definition of what AI, artificial intelligence, is hugely wide. And one thing that I think people need to understand is, in general, game designers and game developers always cheat. If you used absolutely perfect artificial intelligence algorithms to calculate how non-player characters would react and how the game worked, would have no capacity, processing capacity left over to play the game, or the game experience would slow down in a lot of cases, or if it's a massively multiplayer game, it would really start to impact as you put lots of instances together. So in general, what we would class as, or what people would often class as AI in games, is sometimes very unsophisticated. Just almost rules-based. If this happens, do this, and we can get away with some of the lesser characters in games being pretty dumb from an AI point of view. But then the other side of that is when you have fairly sophisticated game behavior. Let's just say in a fighting game, for example, and it's one player versus one AI. You want that AI to be as sophisticated as it can be to give the player the experience of as close to playing a real human being as possible. So it's very, very variable. I think there are many great examples of AI being used well in games, and I suppose the ultimate accolade is when you don't notice it's AI that's driving some part of the game behaviour, and you just assume either it's a human, and that's almost the classic what's called the Turing test. Where you, as a user of a piece of software, if you cannot tell that the user on the other side is human or a piece of artificial intelligence, that would pass the Turing test very roughly. There's slightly more definition than that. But yeah, so when you look for specific examples, I think some of the work that's been done most recently on very sophisticated AI, when you're talking about chess and games like Go, the Chinese board game, have been remarkably good. These are now AI players that can defeat the world's best players. They almost, with the start Big Blue from IBM a number of years ago, there was the very first time that a chess computer was able to beat a recognised grandmaster, and then that really moved on, or the best chess player in the world, and that's moved on now to Go, which is a much more sophisticated game, to the AI algorithms developed by companies like DeepMind in the UK, starting to defeat the world's best Go players, which people thought was impossible. And they're doing it faster and faster. Machine learning algorithms that these systems use, and I think that's something when people talk AI a lot. Machine learning, to me, done properly, really starts to hit the definition of artificial intelligence. So that's where you do not tell the machine how to play. You effectively tell the machine the rules and give the machine examples, let it watch people playing, or actually just play. And because of the vast speed and processing power that you can throw at an algorithm like that, incredibly quickly, it starts off as a novice player, and within minutes sometimes, but certainly over a period of hours or days, it becomes the best player in the world without a human having to tell it anything, or guide it, or say that was good, coach it in a way. And that, to me, is the definition of true machine learning. And I think those board games, those fixed rules board games, are probably the place where we've seen it executed best so far. I think it's quite difficult to show that games have been leading the way in terms of AI. It's more a constant set of parallel developments, where the core fundamental AI researchers are publishing new techniques or algorithms or improvements to algorithms. Games will take them and try them out and show them at reasonably high performance, and then people will take them back again. And the open source communities are by definition very collaborative in this kind of thing. The one thing I do think that games developers are are the best at is marshalling limited resource. You know, I mentioned in an earlier answer that you know, a lot of the time we cheat. You know, when it comes to developing AI, because if we don't really need to run a fully fledged AI algorithm to work out a route finding algorithm, then we won't use the AI. You know, we'll make it deterministic, and we'll have a table of you know, of lookups or whatever the right and easiest solution is. So oftentimes game developers are brilliant at taking somebody else's algorithm and optimizing it, and then that will find its way back into the you know, into the open source community that put, or the academic community that put these algorithms together in the first place. So really efficiency is something we're excellent at. The other thing clearly that we do probably better than anybody is ginormous amounts of user testing, as in when we take an algorithm and throw it out there, if it's in a popular game, millions and millions of people will use it very, very quickly. So we'll see results and improvements that would probably take people in, I don't know, in a business environment or an engineering environment a lot longer to see the results of. So, you know, just by volume, we can make things happen faster than other industries. Clearly, data privacy is something that everybody takes very, very seriously. And whilst no good game developer would specifically harvest player information, I think we all put in you know, metrics and you know, telemetrics that start to give us data that shows how people generically play the game, and shows where the hotspots are, and shows where people are maybe defeating things too easily, which we can use to improve things in time. There's a fine balance, though, between that and changing the game experience. Because what you don't want is a game that plays in a certain way, and then you go away and come back 3 weeks later, and suddenly you can't defeat the level that you previously defeated. So always also depends on the game type, you know, the kind of improvements you would make to things like either non-player character, NPC AIs, or specific puzzles and problems and things that are a bit more adaptive. You know, there's a reason you kind of generally lock down, especially if it's a game with a certain level of progression. The initial design of that progression has to really remain as is. Otherwise, the players are going to get a bit cheesed off that either it gets easier, harder, or different the next time they come back. But those kind of you know, the kind of metrics that we want to look at and evaluate are really just proving hypotheses. Are the game, you know, the game mechanics that we put in place as easy or as hard as we think they are? Do people have undue advantage for certain techniques that we can watch? So we normally have, you know, good amounts of data coming back to us from games, but not specifically. We'd never turn around and say, oh yeah, we've watched player X in Dundee and we're going to specifically do something for them. We don't know who people are. We just know generically what people are doing within the games. Some of the sophistication that's started to be used in terms of AI technologies and algorithms inside games has been made possible because of the incredible improvement or increase in power and technology. One specific area that's worth talking about is GPU, graphical processing units, that are inside the graphics cards that companies like NVIDIA and AMD make. These are pretty specialist in terms of the kind of algorithms and the way you program them, but they are now of the power, or the order of magnitude of power that we were only seeing in things like Cray supercomputers 20 or 30 years ago. You know, full building-sized computers that were costing tens, if not hundreds of millions of pounds, are now on a card that you stick in the back of your PC. You know, people think they're relatively expensive. You know, you can pay you know, £1,000, £1,500 for some of these graphics cards, which, you know, in the world of cheap PCs is expensive. But the processing power that this gives you is almost inconceivable to some of us who were, you know, in computer science, you know, 20 or 30 years ago, that it could happen. So these processors are able to throw power at things like AI algorithms that we just simply didn't have the horsepower to do. And that's led to people trying all sorts of different things. Some of that power, and inevitably, it was designed to be used for cool graphics technologies, but people have found that it's now having a lot of application in AI. And you're seeing outside games, things like automotive sector, where they're trying to use these chips to build their autonomous AI algorithms to drive cars and clearly do image processing and collision detection, all the kind of things that they do on these chips. So these are incredible. That's definitely one of the places. The other area is the rise of cloud computing. So when you look at services, specifically the market leader being Amazon Web Services, AWS, but the others as well. But AWS has unleashed a torrent of capability to try things out that would have required enormous amounts of money and enormous horsepower. You can just basically try the algorithm, dial up enough power on Amazon to see if it works, and if it works and it's useful, keep spending that money on those AWS instances or not. And you can spend small numbers of dollars or cents even trying that out. Whereas before it would have been some massive investment decision for a big company to buy all the computers to do it. And some of those AWS projects have led to things like open AI groups being able to create player bots that can go into massively multiplayer online games and can be, well, not just convincingly show that it's as good as a human player, but actually start to go past human players and play in ways that human players won't if you apply classic machine learning techniques to that. And those aren't the game developers doing that. These are player communities, research communities making some of the stuff available on open source, and then people firing it up on AWS. So you now have this really interesting position where the game will be playing in one instance of processing, and normally you've got people with a keyboard and a mouse interfacing to that, sending signals to play the game. So all you need to do is effectively hijack that interface and put a cloud-based AI player in there. And from the game's perspective, it's a player like any other player. It doesn't impact on the resources of the game. It's just receiving feedback and control it in the way it would normally. And it's incredibly powerful. So AI is creeping into ways that the game developers haven't thought about, the game developers haven't sanctioned. The players are starting to use it for their purposes as well. And some of that's good, but some of that can be pretty annoying and challenging if you suddenly feel that the game that you love and play has been ruined because all these AI bots are coming in and tanking you every time. I think the one thing that everyone has to think through is that any computer program, any instructed machine will only operate in the bounds that the humans that instructed it asked it to. Now, when you talk about AI and you talk about machine learning and you talk about ultimate optimization of whatever algorithm or problem that you've set that particular machine, you have to be incredibly careful. There's no doubt about it. And I think without care and attention to the capabilities of a compute system that's got AI powering it, there could be really, really negative unintended consequences. And there have been, there are definitely two schools of thought out there in the world. There's a strong school of thought where there are people that are incredibly scared about what the future of the human race looks like as AI gets stronger and potentially more in control of more systems. And there are those that are far more optimistic about it. And somewhere in the middle, as per usual, is reality. If you go and look up, Isaac writer famously crafted the laws of robotics within one of his books, but it become a core tenet of the robotics world. And the principle in Asimov's rules of robotics are that a robot can never threaten or cause damage to human life. And I think that rule is the same rule that needs to be applied when you're building systems with a level of artificial intelligence over and above everything. So you need to consider what capabilities that system is in control of, and therefore where can they, where could they impact human life potentially negatively, and build in safeguards. One has to do that from day one, and whether that's fail safes and it's all those things. I mean, those of us that grew up on Terminator, you can see the theory which could happen if unchecked. A piece of AI was left to self-improve and develop and take over more and more of their systems. I think there's a really, really good example to this out in the world at the moment, and it's to do with optimization. And the paperclip maximizer theory is about an optimization task, which is if you give anything, AI or human, the task of optimizing something without thinking about the unintended consequences around it, it can go wrong. And within games, I think there's a very clear example of that going on at the moment within the world of what we call free-to-play mobile, where these games are pretty much designed by data-driven architects. So even sometimes there's AI in there doing this, but most often it's humans that are taking lots and lots of data analytics from their systems and optimizing their algorithms to make more people pay more money. The thing is, our systems and algorithms are so good that we can turn that dial as hard as possible and squeeze every last cent out of certain people by, unfortunately appealing to the same kind of behaviours that gambling hits on as well. It's not gambling. You're just basically trying to hook them more into generally a fairly, I'll use the word crappy, a fairly crappy game experience that's quite Pavlovian. You just press a button and things happen, and then somehow you put a barrier in the way that if you don't pay a bit of money, you get stuck at that barrier for a long time, and eventually a human being says, stuff it, I'll pay a bit of money. Oh, that was good, I got to go quicker. Oh no, it's gone slow again. Oh, maybe if I pay a little bit more money. And a lot of the companies that are building those kind of games, I think, have not put in safety checks and balances in around what is reasonable. So this isn't directly injuring somebody, but sometimes this is, squeezing so much money out of people that they get themselves into daft amounts of debt, or spend so much money on this one particular pursuit that it negatively impacts other parts of their life because they've got no money left for it. And ethically and morally, it's completely wrong. Nobody at that business should have been allowed to do that. They should have stepped back and said, what's reasonable value for this game? We can optimize this up to a point where, I don't know, people pay $100 a month. And at $100 a month, that's a lot of money to anybody. And, you could argue that they've had quite a lot of fun, and versus a subscription to, I don't know, Netflix or cable TV or whatever it is, it's expensive but not crazy. There we go. There's a check and a balance. But most of these businesses don't. Most of these businesses just keep optimizing until some other check and balance kicks in, like their credit card company, boots them off, like they go bankrupt, like they can't afford to pay for food, and have to. I'm being extreme, but have to do something. So I think people need to write in safe checks and balances, but there's no laws around that. So the short answer is, could people develop systems that significantly negatively impact human beings because they're left unchecked to optimize and improve themselves with no check and a balance on what the negative impact was? Yes, that can happen. Absolutely can happen. Should it happen? No, it shouldn't. And developers, governments ultimately, the people who publish and control the distribution of software like this need to step in and ensure that the software that's very AI heavy in terms of optimization has been verified as not having that kind of impact, or carries as strong head warnings as drug treatments in a way. yeah, I think one of the things that definitely has improved the life of a developer is the availability of solutions to component parts of their job. There's no point in reinventing the wheel. And just because I know how to write a compiler from the ground up doesn't mean it's a good use of my time. So I think a lot of the code developments that are out there that are optimized and shared are making life easier on one hand. On the other hand, still the best developers will know how best to put those together, how best to optimize them, how best to ensure that they interact with each other properly. But it does mean that development should continue to be democratized, which is a great thing. One of the problems that the world has had since computers became an important part of it is that kind of, I suppose, the alchemist paradox, where there's somebody in there with the knowledge of how to create this special thing, and they hold it close to their chest and they don't let it out, so they become, they become more valuable, and in a way, the classic thing with alchemists of old, they holding that knowledge, they somehow have an aura of mystique and magic about them. I think developers have had that for a while, and I personally would like to see, the curtain pulled back on that, and anyone being capable of at least prototyping systems to perform useful tasks. And I think that's happening more and more, and take away the fear of, oh my God, I don't know where to start. Well, get out into Google and Google solutions, get out into open source and build some of these things that are there and play with them, because you'll find that you'll be able to get most of the solution yourself. And Minecraft is a great example of this. Notch, the guy who founded and who invented and created Minecraft, is a great programmer, but he's definitely a great, I'd call it, and I mean this in a very positive sense, sort of hacker indie developer. He doesn't really necessarily care about, is it the best technology solution, but does it work and will it make my game fun? So he concentrated entirely on getting a game up there that achieved his vision, answered the questions and the requests that his players had as quickly as possible, and he didn't really worry about how optimal it was and how well it would scale up to millions of players on a Nintendo Switch. And then we came in, so we came in and took his vision, executed in Java and not particularly efficiently, and put some incredible engineers on making it hardware specific, making it work and optimizing it, both technically but also from a gameplay perspective. And that was a great thing. It was a great thing that he didn't have the shackles on him of having to worry about every machine cycle and performance criteria. He was able to go and be creative on a large scale, and then let others worry about ensuring that it was optimally developed. And I think that's the model that we'll see. I want people who are not necessarily the greatest engineers in the world to be able to build systems and have fun with them, but then partner with great engineers when they become useful to optimize and make them work on a large scale.